Good morning, students. Hemant?
Good
Hemant,
morning, sir.
good
Sir,
morning. Okay, my voice is audible?
yes, sir.
Okay, right. So in the module 3, last topic, that one is biodegradable polymers. So previously we discussed about the polymers, classification of polymers with examples. Classification of polymers are addition polymerization, condensation polymerization, and copolymerization. And next, coming next topic, plastics. What are the plastic? What are the uses of plastics? And how the plastics are classified, that we discussed. Plastics are classified into two types, thermoplastics and thermosetting. And thermoplastics, which are on heating, soften and cooling harden. Thermosetting after molding process that can't be softened, they become hard only. So like that materials are called as thermosetting plastics. So compounding of plastics. Compounding of plastics means in the molding process we are adding some additives to the polymer compounds. So when we are adding the additives to the polymer compound, then they will show their properties. So that compounding of plastics are resins, plasticizers, fillers, and pigments, colorants, lubricants, antioxidants, fire retardants, stabilizers, etc. These all are the compounding of plastics. Next, coming next topic, that is preparation properties and applications of PVC, Teflon, nylon 66, and bakelite. These already we discussed. So very important questions. Important one: which types of polymerization? Difference between the thermoplastic and thermosetting, and preparation properties applications of PVC, Teflon, bakelite, and nylon 66. Nylon 66. Among these, so in the examination point of view, they will ask the preparation properties applications of following. Any two they will give. Polyvinyl chloride, Teflon, or polyvinyl bakelite, or nylon 66 or Teflon, like that they will give. That is for 7 marks question, or 7 or 14 marks question. Okay. Now last topic in the module 3, half of the module, that is the biodegradable polymers. So what are the biodegradable polymer? Anyone know about biodegradable polymer?
Decompose easily.
Very good. The polymers which are easily decomposable. The polymers which are easily decomposable, that are called as biodegradable polymers. Suppose you see, so this mask, these all are the disposable mask. These are the disposable mask. So this mask easily dispose. That means easily disintegration takes place, easily deformation takes place. Okay, when these masks are reaction with the bacteria, fungi, etc., then degradation takes place. So like that, polymers are called as biodegradable polymers. The polymers which are easily degrade or easily decompose or easily deformation takes place, like that polymers are called as biodegradable polymers. Suppose you see, so this water bottle is there. So this is not the biodegradable polymer. This does not undergo any deformation easily, deformation disintegration easily. Why? Because so that's why we are not called as a biodegradable polymer. Polythene covers are then polythene covers that fruits we are carrying the fruits. So that covers up to thousands of years when we are processing takes place, does not undergo any deformation or disintegration. Polythene covers are there now. Polythene covers, water bottles, etc. When we are recycling takes place, that is different, but does not undergo any decomposition. If the material, if the articles which are easily decomposable, when reaction with the bacteria and fungi, bacteria or fungus, then that materials, that product undergo decomposition. So like that polymers, like that materials are called as biodegradable materials or biodegradable polymers. The polymers, if the materials are polymers, that is biodegradable polymer. The materials are other material. So that is a biodegradable polymer. Now, so biodegradable polymer is defined as Biodegradable polymers are defined as degradable polymers in which degradation results from the action of naturally occurring microorganisms as bacteria, fungi, and algae. So when disposal mask is there, na? So when disposable mask easily undergo, when the mask is easily reaction the bacteria, fungi, alkali, then easily undergo deformation or disintegration, degradation takes place. So like that materials are called as biodegradable polymers. A plastic that undergoes degradation by biological process during the composting to yield CO2, water, inorganic compounds and biomass at a rate consistent with other compostable materials and leaves no visible distinguishable or toxic residue are called as compostable plastics, are called as compostable. The biodegradable polymers may be naturally occurring or may be synthesized by chemical means. In addition, feedstocks to synthesis of these biodegradable polymers may come from a processing of crops grown for the purpose or the byproducts of the of other crops along with chemical and biochemical process. So these biodegradable polymers are mainly they occur as a naturally occurring biodegradable polymers and synthetically occurring biodegradable polymers. So these are mainly where we are getting from crops grown and products other crops along with chemical and so synthetics are we are prepared by chemical and a biochemical process. Naturally occurring biodegradable polymers are starch, cellulose, silk, wood, and gelatin, polyhydroxy alkanoids, and lignin, etc. These all are the synthetically biodegradable polymers. So these biodegradable polymers are classified into two types that are synthetically biodegradable polymers and naturally occurring biodegradable polymers. So biodegradable polymers are two types. So that are naturally occurring biodegradable polymers. Number two, synthetically occurring biodegradable polymers. So what are the naturally occurring biodegradable polymers? A wide variety of naturally occurring polymers are available. The fact that these substances were polymers was not known. In many quarters, this ignorance persists. The naturally biodegradable polymers are classified into four groups as given below. So that are, listen carefully students. So naturally occurring biodegradable polymers are four types. What are they? So these are the introduction to the biodegradable polymer. So number one,
Or you are in mute.
Sorry. So naturally occurring biodegradable polymers are mainly classified into 4 types. Number 1, polysaccharides, proteins, polyesters, and others. So what are the polysaccharides? Polysaccharides are cellulose, starch. And what are the proteins? Proteins are silk, wood, gelatin, etc. Now, what are the polyesters? Polyesters are polyhydroxyalkanoids. These polyesters are polyhydroxyalkanoids. Others are lignin. So these were the naturally occurring biodegradable polymers are mainly classified into 4 types: polysaccharides, proteins, silk, wood, polyesters, and others. So polysaccharides are cellulose and starch. Proteins are silk, wood, and gelatin. And polyesters are polyhydroxyalkanoids, and others are lignin. Just these all are the introduction to the biodegradable polymers only. No need to write in the examination point of view. So synthesize the synthetic biodegradable polymers. So synthesized synthetic biodegradable polymer. There are many polymers produced from derivative from the petrochemical or biological sources that are biodegradable. So the synthesized biodegradable polymers are many types of biodegradable polymers synthesized. In that there are number of the biodegradable synthetic resins that are polylactic acids and its polymers, polyvinyl esters, polyvinyl alcohols, polyamide esters, etc. These all are the synthetic biodegradable polymers. So synthetic biodegradable polymers are polylactic acids, polyvinyl esters or polyvinyl acetates, polyvinyl ester, polyvinyl esters, polyvinyl alcohol, polyamide esters. These all are the synthesized biodegradable polymers. So how to synthesize, how to prepare the polylactic acid, and how to prepare the polyvinyl ester, that is our syllabus. So in the examination point of view, they will ask about the preparation, properties, and applications of polylactic acid, and polyvinyl acetates. So polylactic acid is simply called as PLA, and polyvinyl ester PVA, polyvinyl ester PVA. So this preparation, properties, application we will discuss one by one. Okay. So synthetic biodegradable polymers, in that in the examination point of view, according to our syllabus, only we are discussing about the polyvinyl estate and the polylactic acid. First we'll discuss about the polyvinyl estates. So PVAC, that is polyvinyl estates, polyethylene ethanoate is rubbery synthetic polymers with the formula of C4H6O2N taken. So these polymers are taken in times. It belongs to the polyvinyl ester family with the general formula of RC double bond CHCH2. It is a type of thermoplastic. So these polyvinyl esters are there. Polyvinyl estate, polyesters are polyethyl alcohol or polyvinyl esters, polyvinyl esters, etc. are there. So that all are the thermoplastics only. It contains a long chain hydrocarbon atom. There is no branch structures are present. So that's why that all are the thermoplastics. It should not be confused with the related to polyvinyl alcohols, which is also called as a polyvinyl acetates, PVA alcohols or acetates, etc. Also PVA, polyvinyl alcohols or polyvinyl acetates, PVAC, polyvinyl acetate is a vinyl polymer. Polyvinyl acetate is a prepared polymerization of vinyl acetate monomer. Free free radical vinyl polymerization of the monomer of vinyl estates. So vinyl estate undergo free radical vinyl polymerization, that we are getting the vinyl estate, PVAC. Polyvinyl estate. Polyvinyl alcohol is the PVA. Polyvinyl PVAC means polyvinyl estates. So these polyvinyl estates, how to prepare polyvinyl estates? The polyvinyl estates are prepared by vinyl estate undergo free radical vinyl polymerization. Then we are getting the polyvinyl estate. The degree of polymerization of vinyl estate is typically 100 to 5000. So degree of polymerization means how many repeated linking of vinyl estates are there? That is the degree of polymerization. Degree of polymerization of polyvinyl estates are 100 to 5000 number. The ester groups of the polyvinyl estates are sensitive to base hydrolysis and will slowly convert PVAC to polyvinyl alcohols and acetic acid. So this polyvinyl alcohol, polyvinyl estates, when hydrolysis takes place, slowly it convert into PVA, polyvinyl alcohol and acetic acid. How to prepare the polyvinyl estate? Let us discuss one by one. Okay. Preparation. So polyvinyl acetate. This polyvinyl acetate is prepared by vinyl acetate. The structure of vinyl acetate is H2C double bond CHO C double bond O CH3. This is the hydrogen. Okay, H2 vinyl acetate undergo free radical vinyl polymerization. We are getting the H2C CH taken in times O C double bond O. So this is called as polyvinyl acetate. How to prepare the polyvinyl acetate? Polyvinyl acetate is prepared from vinyl acetate undergo free radical vinyl polymerization. That we are getting the polyvinyl estates. So this structure write on all of you. All the students write down the polyvinyl acetate preparation. Make it fast. All of you written the structure? Anyone can respond. So properties of a polyvinyl acetate, listen carefully. So properties, the the polyvinyl ester family has been general formula is RC double bond O CH double bond CH2. CH double bond CH2. If double bond is not there, then We are making it as a okay. So this is the general formula of vinyl esters. R C double bond O OCH CH2. So this is the polyvinyl esters formula. The most important number of polyvinyl ester is the most important member in the polyvinyl ester. It contains 100 to 5,000 degree of polymerization. 100 to 5,000 degree of polymerization. It is completely highly branched non-crystalline thermoplastic. It is non-crystalline and highly branched structure, non-crystalline, prepared by convention of free radical mechanism, free radical polymerization. The homopolymer has glass transition temperature around room temperature. It is a good resistance to UV and oxidation. It is a good resistance to UV and oxidation, but is rather brittle below the transition temperature, and it has because of the water sensitivity of the homopolymer, PVAC, that means polyvinyl ester, is generally viewed as a inappropriate for exterior uses. This one is not used for inappropriate for external uses. So PVAC, that means polyvinyl esters are often used for adhesives, water-based emulsions are by far the most common form of form in which polyvinyl esters are used in a adhesive market. The adhesive properties are generally affected by the molecular weights. That means molecular weights effects. The compatibility of the vinyl ester with the other ingredients. The adhesive strength and moisture sensitivity also depends on the type and the amount of protective collateral, that means gelatin, natural gum, and cellulose, etc. So this PVA, polyvinyl esters, is not only the vinyl ester. Other vinyl esters have been synthesized by using the polyvinyl esters. Now, these are mainly the properties about this one is this is the crystalline compound and the thermoplastic. This is the thermoplastic and resistance to UV and oxidation, resistance to sunlight, moisture, acid, alkali, etc. and improve their flexibility. So these are the properties about the polyvinyl esters and applications. Now, so this is now all of you understood the preparation. How to prepare this one? Polyvinyl ester is prepared by vinyl ester undergo free radical vinyl polymerization, that we are getting the polyvinyl ester. So this polyvinyl ester properties are these are the crystalline structure, long chain hydrocarbon atom. It contains branch structures, thermoplastics, resistance to UV, oxidation, sunlight, moisture, acid, alkali, etc. Okay, this is structure preparation. So these are having the adhesive properties, already discussed applications. And these are envelope adhesive as a wallpaper adhesive. They shift a copolymer PVC, but more soft copolymer, a combination of a vinyl acetate and ethylene. Vinyl acetate ethylene is used for paper coating, paint, and other industrial coating as binder, non-ovens in a glass fibers, sanitary napkins, filter papers, and in textile finishing. Polyvinyl is also used as a coating to protect the cheese for fungi and humidity. Polyvinyl is also used for raw material to make other polymers like polyvinyl alcohols. By using the polyvinyl acetate, we prepare the polyvinyl alcohols. Polyvinyl acetate is prepared from ethylene by reaction with oxygen and acetic acid over a palladium catalyst under the action of free radical initiators. Vinyl acetate monomer is formation takes place. That vinyl acetate monomer then undergo polymerization that form as a vinyl acetate. So this is about the polyvinyl estate. Listen, you see students, the polyvinyl estate, how to prepare polyvinyl estate, vinyl estate under polymerization, that form is polyvinyl estate. In the free radical vinyl polymerization, we are getting the polyvinyl estate. Polyvinyl estate is the resistance to sunlight, moisture, acid, alkali, UV, and oxidation, and crystalline structure, branch structure, thermoplastic. These are the thermoplastics, etc. The applications of that one is these are mainly having the adhesive property. PVC is produced to use the adhesive market. It is one of the main ingredient of water-based glues, commonly referred as wood glue, carpenter glue, etc. PVC is not generally used for primary fasteners when great strength is needed. That polyvinyl estate to find additional uses of plus sizes, thickness for paint, thickness for the paints, textile finishes, plastic and cement additives, chewing gum. By using this polyvinyl estate, we have prepared the chewing gums also. Polyvinyl estate is a notified cheaper than the acrylic resins, approximately half of the cost of acrylics. So these polyvinyl estates these are the very cheap when we compare with acrylics. So, however, the best exterior water-based paints are 100% acrylic due to the elasticity and other factors. So these all are the properties about the polyvinyl acetates. So polyvinyl acetates are mainly we are used as a adhesives, and mainly we are used in paints and chewing gums, etc. And textile finishes, plastic, cement additives, etc. We are used. Next, coming to one more biodegradable polymer, that is polylactic acid. Polylactic acid. So this polylactic acid. So this polylactic acid is then these polylactic acids are mainly by using this one polylactic acid we are prepared the surgical devices like mask, stitches, and medicinal devices, etc. We are prepared. So this easily decomposition takes place. Lactic acid, first lactic acid form as a lactide. When the lactide formation takes place, lactide ring, that lactide contains a ring structure. So the ring structure. So this polylactic acid or polylactates are there. This polylactic acid, polylactates are mainly we are using medicinal uses, surgical operations like mask, preparing a mask and stitches. By using the medicinal applications, we are using the polylactic acid, lactic acid. It is a thermoplastic aliphatic polyester derived from renewable resources such as cornstarch, in which United States, etc. Carboxylic acid and alcohol and groups are thus concentrated in the amorphous region of the solid polymer, and so they can react and form polylactic acid, and they can form polylactic acid. So this lactic acid, polylactic acid, how to prepare polylactic acid? First, we are preparing the lactic acid. First, lactic acid form as a ring structure. That ring structure open takes place, then we are form as a lactate or polylactic acid. So what is a polylactic acid? Polylactic acid is lactic acid. Lactic acid is a chiral compound. So the structure of lactic acid is so S3CCOH H So this is the lactic acid. So this lactic acid carbon is there now. So this carbon, what is the chiral compound? Why we are called as chiral compound? Anyone? Anyone can respond? Why we are called as a chiral compound? Anyone? Please raise your hand. Or anyone
It
can
attached
respond?
to it attached to 4 different groups.
Very good, nice. Then carbon is attached to 4 different groups. That is called as chiral group. Chiral group. Carbon is attached to one carbon. You see, hydrogen is different, carboxylic is different, hydroxyl group is different, and methyl group is different. So this carbon is called as chiral carbon. This carbon is called as chiral carbon. This carbon having the 4 different groups. So that are called as chiral group. So now OH, HC double bond O, OH. So lactic acid form as a lactate. The structure of lactate is, listen, all of you see the structure. Double bond O, CH3, CH3. So this is called as lactate. Now this lactate undergo polymerization. We are getting the polylactic acid. CH3, C double bond O. C, CH3, C. So this is taken attention. So this is called as polylactide or polylactic acid. So lactic acid, the form is a lactate ring structure. So this ring is opening takes place here. You see, ring opening takes place. ROP. So ring opening polymerization takes place. Then we are getting the polylactate or polylactic acid. This is the structure of polylactic acid. Sorry. Okay, this is a preparation of polylactic acid. The properties. In the properties of polylactic acid, polylactide, due to the chiral nature of lactic acid, several distinct forms of polylactide exist. So that is L-lactide formation takes place. This polylactic acid, that means L-lactide having a crystallinity around 37%, glass transition temperature between 60 to 65 degree temperature, and the melting point is 173 to 178. However, heat resistance of a polylactic acid can be withstand temperature, that is 110 degrees centigrade temperature. PLA is soluble in chlorinated solvents, hot benzene, tetrahydrofuran, and dioxane. So these properties of this one, this is a chiral compound having distinct properties. Having a crystalline structure, thermoplastic resin only having the glass transition temperature 60 to 65 degrees centigrade temperature. Melting point is 173 to 180 degrees centigrade temperature, and withstand high temperature up to 110 degrees centigrade temperature. And this polylactic acid soluble in chlorinated solvents, hot benzenes, tetrahydrofurans, and dioxin, etc. Applications. So these are mainly the polylactic acid or polylactates are mainly we are used in medicinal applications. Like being able to graduate to innocuous lactic acid. Polylactic acid is used in a medical implants in the form of screws, pins, rods, and as mesh, depending on the exact type used. It breaks down within the body with the 6 months to 2 years. This gradual degradation is desired for support structure because it is gradually transfer the load to the body as a area of heal. So when in the medical implants, we are using the screws, pins, rods, and meshes, etc. We are using so that are easily disposable. That means easily degradation takes place in our body for a particular time of period, that is 6 months to 2 years. It is useful for producing the loose fill packing, compost bags, food packaging, and disposable tableware in the form of fibers and non-woven textiles. Polylactic acid also has many potential uses. For example, disposable garments, feminine hygiene products, and diapers. PLE is also used for feedstock material in 3D printing printers such as riprap and make boards and maker boards. So these all are the applications of polylactic acids. So these mainly we are used, polylactic acids are mainly we are used in medicinal applications, and one more is for making a disposable bags, food packing, and disposable tablewares, etc. And also PLE, polylactic acid also used in 3D printers such as reprep and maker board, etc. So these all are the applications about polylactic acid. Properties, preparation, properties, and applications about polylactic acids. Polylactic acid based on the polymer available for controlled drug release, implementable composites, bone fixation parts. So this polylactic acid mainly we are using bone fixation parts, packaging and paper coating, and sustained release systems for pesticides and fertilizers, and compost bags and compost bags. Histological studies indicates that the polylactic acid is non-toxic, non-tissue reactive, and biodegradable. These all are the applications about the polylactic acids. Preparation, properties, and applications. And also these are mainly used in medicinal applications like suitable stitches, vascular grafts, and other surgical implants, etc. We are also used, okay, in breaking of bones, etc. The purpose we are using this polylactic acids materials. So application. So this is about the biodegradable polymers. So that are biodegradable polymers are polylactic acid. One is the polylactic acid, and one more is polyvinyl acetate. That preparation, properties, and applications are the very important for you. This is about 2.5 module for CIE 1 examination point of view. Tomorrow onwards we will discuss about the question bank. Okay. Hemant. Ananya.
Yes, sir.
ఎవరు
అనన్య.
ఆబ్సెంటీస్ ఏమన్నా గుర్తుందమ్మా, చెప్పారా?
లేదు సార్, ఇప్పుడు చూడాలి.
చూస్తావా? చూసి ఎంతసేపు అమ్మా అనన్య?
హలో
హలో.
సార్ మీ వాట్సాప్ కి పంపాను.
వెరీ గుడ్. అమ్మో, యూఆర్ టూ ఫాస్ట్. థ్యాంక్ యూ.
ఓకే సార్.
ఓకేనా? టుమారో ఆన్వర్డ్స్ విల్ డిస్కస్ అబౌట్ హోంవర్క్. రాసినావా నువ్వు? Are you written homework?
Yes, sir.
Tomorrow, what you can do, all of you, all the students, you have to write down the preparation, properties, and applications of PVC, PVC and Teflon, Bakelite, and nylon 66. Okay, preparation, properties, and applications. 3. Just you spend for 10 to 15 minutes, it will be complete. Okay, all of you.
Yes, sir.
Next our class ఏంటి?
Lac.
అదే చూసి తప్పు చూసి చైతన్య
చెప్పకూడదు మ్యాథ్స్ వాళ్ళ గురించి చెప్పకూడదు.
Students, Hemant,
శ్రీలత క్లాస్
Hemant,
Sir.
Hemant.
Yes, sir.
Okay, maths, unfortunately, maths made not came today.
Okay, sir.
ఎవరే అంత సంతోషం ఏందా నీకు మెల్లగా మాట్లాడాలి.
Sorry, sir.
No problem, no problem. What you can do, you have any doubts, students, listen here. You have any doubt, once you see the question bank, I think all of you having question bank na?
Yes, sir.
Question bank question చూడండి ఒకసారి అందరూ, each and every student.
Yes, sir.
Myself also, I am also suffering with somewhat cold and cough. Okay? తెలుసా వీడు కూడా
సిక్స్త్
తెలుస్తుంది ఇక్కడ నాకు, ఎవడ అరుస్తున్నాడో తెలుస్తుంది ఇక్కడ నాకు. హలో, ఇక్కడ ఎవరు అరుస్తున్నారో తెలుస్తుంది నాకు. ఇక్కడ డైరెక్ట్ ఇక్కడ వాళ్ళ రూల్ నెంబర్ వస్తుంది, అల్లరి చేయదు. సరేనా?
తప్పు చూసావు.
Okay, sir.
ఓకే.
థర్డ్ అవర్ 6th అవర్ క్లాస్ ఉంది. థర్డ్ అవర్ ఇప్పుడు రాజు అడ్జస్ట్ చేసిండు.
ఇప్పుడు
అడ్జస్ట్ చేయండి.
in module 3, listen students, in module 3, addition polymerization, condensation polymerization, types of polymerization, plastics and compounding of plastics, preparation properties and applications of nylon 66, bakelite, PVC and Teflon. You have and biodegradable polymers. You have any doubts? Please raise your hand. Anyone? అమ్మా
కొత్త సరకే వస్తాయి.
అప్పుడే వరకు ఇస్తుంది.
ఆయన అందుకే గోర చేస్తున్నాడు కదా. ఇప్పుడు ఈ కొత్త సరికి ఇంటి ఇచ్చాను అనుకో,
మీరు ఏమంటున్నారు చెప్పండి.
నేను ఇంద్రా వాడానికి ఎంత తీస్తామా
హేమంత్,
ఈయనకి ఇస్తాను. చాంతకి ఆల్రెడీ ఉంది.
హేమంత్,
Sir.
screen is sharing now. Bakelite is there.
Yes, sir.
Okay, students, all of you, what you can do, just you practice the reaction. This bakelite preparation is a very, very important. All of you practice this reaction. Make it fast.
నేర్చుకొని ఇక్కడ సాఫ్ట్వేర్ కంపెనీలో జాబ్ కొట్టి ఆన్సైట్ మీద అయిపోతే
అంత ఈజీయా క్లాసెస్ అర్థం
Okay, are you practiced this Becquerel structure? All of you,
మ్యామ్ మీరు కూడా
students, listen here. Are you practice or not? Now all of you write down the applications of properties of these Beckelites. Make it fast. Rule number 15. Who is rule number 15? Who's rule number 15? 15, rule number 15. Rule number 11. Rule number 11. Aparna. Aparna. Anyone can respond, na? Aparna. అమ్మా వినేస్తలేదా అమ్మా పిలిస్తే? అపర్ణ.
అపర్ణ ఎవరు సార్?
అపర్ణ ఎవరు? అపర్ణ కాదు కదా, ఇక్కడ పేరు వస్తున్నారు.
చాలా ఫోర్స్ఫుల్లీ
రూల్ నెంబర్ 13. Who is 13? Rule number 13. ఎవరు? ఎవరు 13? ఎవరు? ఒకసారి వీడియో ఆన్ చేయి, ఒకసారి చూస్తా.
I am writing, sir, now.
Okay, రైటింగ్ నా? రైట్ డౌన్, రైట్ డౌన్. వెరీ గుడ్.
సెటిల్మెంట్ చూసుకోవాలని అనిపిస్తుంది. మా చెల్లి అయితే ఏమంటుందంటే అవన్నీ వేస్ట్, ఎడ్యుకేషన్ మీకు వస్తే.
51. Who is 51?
హిట్లర్.
Rule number 51. 51.
బెస్ట్ ఐడెంటిటీ.
51 ఎవరబ్బా?
ఇన్స్టాగ్రామ్
రేపు పిలిచి అస్సలు పలకరు ఎందుకే? నేనే కమ్ముంటా. All of you write down the properties of bakelite. Make it fast in your classwork. Tomorrow I will check all classworks. I will check tomorrow. Okay. Each and every student's classworks. You have to maintain the classwork. Tomorrow I will check your classwork notes. So in the classwork notes, you have to write down the addition polymer, condensation polymer with examples, differences between the addition condensation, and difference between the thermoplastic and thermosetting, and preparation properties applications of PVC, bakelite, nylon 66, Teflon. Okay.
Yes, sir.
సార్ ఒక్కసారి మళ్ళీ చెప్పరా?
Difference between the addition polymerization and condensation polymerization. Difference between the thermoplastics and thermosetting. Preparation properties and applications of polyvinyl chloride, Teflon, bakelite, and nylon 66. These 3 questions is enough for you. Okay.